Hi, welcome to the portal. So in this video we're going to learn how to solve linear equations using Cramer's rule. Okay guys, so let's get into it. So we'll find that we have an equation that consists of our variables. Let's say we have three variables like this. So we have a matrix that represents our coefficients, okay, and also we have a matrix that represents our variables and a matrix that represent the right hand side of the equation. Okay, so now let A be a matrix of coefficients. Let A be a matrix of coefficients. So in this case our coefficients here, we have 1, we have 0, we have 2, and we have -3, we have 4, we have 6, we have -1, we have -2, we have +3. Okay, so that is A. Okay, so I'm interested in A and B as well. So B, I can see that B is 630 and 8. Alright, okay, so now remember our aim is to solve for x1, x2 and x3. Okay, so now this is what is going to happen. So we are going to use our knowledge of determinants in solving for these variables. So now according to Cramer's rule, if we want to find x1, for example, this is what we are going to do. So we are going to find the determinant of a1 divided by the determinant of a, right? And x2 as well, we are going to say the determinant of a2 divided by the determinant of a. Also x3, we will say the determinant of a3 divided by the determinant of a. So now you can see me, I'm saying a1, a2, a3, but here we only have a, we don't have a1, a2, a3. So a1 and a2 and a3, this is how we are going to get a1, a2 and a3. Okay guys, okay, so let me try to copy this matrix here so that we can use it at the bottom. Okay, okay, that's more like it. Alright, so this is matrix A, right? And then remember B. What is B? B is it's a 638, okay, 630 and 8. Alright, so now here's what we're going to do. Now we are going to find a1, a2 and a3. So when we say a1, this is what we will do. We will take the entries of B and replace the column 1 of matrix A. So because of we will have replaced column 1, we will call that resulting matrix as what? As A1. So now this is A1 coming. Matrix A1, let me use the color. So matrix A1 is equals to now because we have replaced the first values here, the first column, it will be 630 and 8. Okay, so now and then these ones, they remain as they are: 0, 4, -2 and 2, 6 and 3. Okay, so because of we have replaced column 1, then we will call this matrix A1. Okay, so and then A2. So because here we are going to replace column 2, so I'm going to write the first column as it is. Alright, so now we will replace the second column with B, with matrix B. So 630 and 8. Okay, and then now I have 2, 6 and 3. Okay, so now you can guess A3 because it's obvious, isn't it? Okay, so now here we're going to have 1, -3, -1, 0, 4, -2. So we'll replace the last one with that B, 630 and 8. Okay, so now this is what we have now. So according to this these equations, so meaning we are going to calculate the determinant of A1 and then the determinant of A2 and A3. So we need the determinant of A1, A2 and A3, and also we need the determinant of A. Okay, so now I will only show you with A1 only, so meaning I will only calculate the value of x1, because if I calculate everything, the video is just going to take so long. Okay, so you can calculate A2 and A3 as an exercise. So okay guys, so let's start by calculating the determinant of A. Okay, let's calculate the determinant of A first. Okay, so now let's continue. We can use several methods of calculating the determinant. Okay, so now I will choose cofactor expansion to calculate the determinant. Okay, so I will use the first row because I can see that we have a 0 in there. Okay, so now okay, so I will say now this one multiplied by, so now if I block this one and that one, so I will have 4, 6, -2 and 3, so minus 0, okay, plus 2 into, so if I block this column in this row, I will have -3, 4, -1, -2. Okay, so the determinant would be 4 times 3, which is 12, 12 minus into minus 12. Okay, so here plus 2, so here -3 times -2, it's 6 minus into minus 4. Okay, so now here I have 24, here plus 6 plus 4 is 10, here I have 20, so meaning now I have 44. Okay, so 44 is the determinant of A. So what about the determinant of A1? So the determinant of A1, let's try to calculate it. Determinant of A1, okay, so we can also take the top row. Okay, so we can say 6, and then if we're taking 6, we're blocking this column and this row, so we have 4, 6, -2 and 3, so minus 0 plus 2, and then here we would block okay, so they would block okay this column and that row. Okay, so here we would have 30, 4 and then 8, -2. Okay, so now the determinant of A1 would be, here I would have 6 into 12 minus into minus 12, so it's 12 plus 12. Okay, and then plus 2 into -60 and what, -60 minus 32. Okay, so I will have 6 times 24. Okay, 6 times 24 here, plus -60 minus 32, it's a -92, so 2 into -92. So the result here would be 6 times 12 plus 2 into -92. The answer would be -40. -40. So we would have that x1 is equals to, now the determinant of A1 determinant of a1 divided by the determinant of a. So the answer would be negative 40 divided by 44. Okay, so the answer would be negative 10 over 11. Okay, so you can continue to find other values of x. Okay, you can pause the video and find other values of x, which is x2 and x3. So that your answer would be, okay, so these are your answers for a2 and a3 for, yeah. So now you know how to use Cramer's rule to solve linear equations. Okay, don't forget to like, share and subscribe. Thank you.